Welcome to Spring Lib.
The first thing we're going to do is convert the velocity, the initial velocity from kilometers per hour to meters per second, which we know how to work with. So, 1 kilometer is 1,000 meters, so that's 95,000 meters per hour. Want to convert that to meters per second, so we multiply by 1 over 3,600. So that's 1 hour per 3,600 seconds. And as you can see, the hours cancel out. We get 26.38 meters per second as the initial velocity. Okay, that's step one. Step two is using Newton's second law. And so the net force is equal to mass times acceleration. And so in this case, mass times acceleration will be equal to the stretching force of the spring, so negative kx. And therefore, x is negative k. Not negative k. X is negative ma over k. All right. Okay. So once you have that, you can move on to the next step, which is energy conservation. Okay, and so for that, we use we equate the initial kinetic energy, which is 1/2 mv naught squared, to the elastic potential energy, 1/2 kx squared. The 1/2s cancel, and now we replace x with what we know it to be, which is negative ma over k, and so that's k times. On the right-hand side, you have k times negative m over k times a squared. Okay, so moving on to the next page, we have mv naught squared equals to k times m squared over k squared times a squared. Okay, and so one of these k's cancel, one of these m's cancel. What you get is v naught squared, or let's write things down in terms of k now, because k is what we want. So what you get is k is equal to ma squared over v naught squared. And remember, a is just maximum acceleration, which is 5g. So m times 5g squared over v naught squared. In other words, 5g squared is 25g squared. So that's 25m times g squared over v naught squared. And so we can plug in numbers now. K is 25 times mass, which is 1,200 kilograms, times acceleration due to gravity, 9.8 meters per second squared, quantity squared, over v naught squared, which is 26.38 meters per second, quantity squared. And this gives us 4,100 newtons per meter as the spring constant needed.